All right, so this will be our last topic we put in our notebook for quadrilaterals. So this is topic 5. Last topic we looked at finding the missing angle. Today we're going to look at finding a missing side length. So you can just title this missing side. So we will again use the properties of quadrilaterals and specific types of quadrilaterals to find the missing side of a quadrilateral. All right, so we're going to flip to Q5, which is right after Q4 on finding the missing angle. We're going to be finding the missing length of a side. So using some of our properties that we know or characteristics we know about various quadrilaterals, we can do that. So first property we have here is dealing with parallelograms. So we know that opposite sides of parallelograms are congruent. So I'm dealing with a parallelogram and I know that because it is titled here. It tells me to find the length of side CD, which is right here. This is the side that has the X that we're looking for. Find the length of side CD in parallelogram ABCD. So if this is a parallelogram, I know that opposite sides are congruent. So this left side and the right side, I know are congruent. I'm going to draw those little hash marks on there to notate that. And they are both 7 centimeters. So that would make sense. So I know that then this long side up top would also be the same length as this long side on the bottom. So again, we're looking for side CD, which is the bottom here, that X number of centimeters we're trying to find. I don't have to really do any math here other than recognize that this is the same length as this. So if AB, which is opposite it, which is going to be congruent to it, is 18 centimeters, that means that side CD on the bottom is also going to be 18 centimeters. So I can go ahead and write that in. So the X is basically 18. The centimeters was already labeled, but the length is 18 centimeters. Now, the question below that asked me to find the perimeter. So if you remember, finding perimeter, we're going to add up all of the sides. So for perimeter, I'm going to kind of write P for perimeter. And again, it's just adding up all of the sides. We'll go a little bit more into our formulas unit later in the year. But again, perimeter of any shape is adding up all the sides. So I'm going to start here with the 18 centimeters for AB, and then I keep going around. BC is 7 centimeters, so I'm going to add that, plus whatever DC is, which we just solved, that is 18. So if you want to write this down in here kind of next to that as well, you can. And then I'm going to add DA, which is 7. So when I add all of those up, and you are welcome to use Desmos to help you out, you are adding up 18 plus 7 plus 18 plus 7, which would give me a total of 50. And my units I was dealing with were centimeters, so that would give me a perimeter of 50 centimeters. I'll go ahead and box in my answer up here too so that we can easily find our answers for each of these. All right, so if I go down to this middle section here with number 2, this is kind of the next property we can use here, is that if you know the perimeter of any quadrilateral, or the area of a rectangle, which we'll get to in a moment, you can find the missing side. So this is really starting to use some of our formulas that we would already know from previous years. So again, if you are if you know the perimeter of any quadrilateral, it can be this kind of crazy looking shape that doesn't fit into any other category. It could be a square, a rectangle, a rhombus, a trapezoid, a parallelogram, an isosceles trapezoid, any type of quadrilateral. If I know my total perimeter, then I can find my missing side. So I have find the length of side YZ. So YZ is right here. It's the side that I do not have anything labeled. I'm just going to kind of squiggle that line so that we can find it easily, or you can highlight it if you have a highlighter. That's what we're looking for. We know that all of the sides together need to total 180 degrees, or excuse me, 180 inches rather, I'm sorry. Need to total 180 inches because that is the perimeter of that quadrilateral. So perimeter, again, is adding up all the sides. So I'll plug in the sides that I know. So I'm going to start here with WX is 40 inches, plus, then I go around the side here, XY is 15. I do not know what this is. I can call this, I could call it X as using that as a variable, but I'm going to call it a different variable so I don't get it confused with that angle. I'm going to call this side N just so I have a number to put in here. So plus whatever the length of N is, plus, and then this last side right here, the 70 inches. So that would be my perimeter. So what I'm going to do now is I'm going to take my perimeter, which is right here. That's my perimeter, and I'm going to plug it into my equation. So I have 180 is equal to 40 plus 15 plus N plus 70. Now I'm going to combine like terms like I did when I was finding a missing angle. So I'm basically going to add up all the numbers and keep the N because I don't know what the N is yet. So I'm going to have to add up 40, I'll do this in Desmos, 40 plus 15, I don't know what N is yet, so I'm going to skip that, plus 70. So I'm adding up the sides that I do know, which would give me 125. So these ones that I know here, I'm adding those up and I get 125. So 125 for those other three sides, plus whatever the value of N is, would have to equal 180. Well, now I have an equation to solve, one-step equation, right? So I would box in my variable and what's with it. I would subtract the 125 to get the N by itself. That cancels, and N is going to be equal to 180 minus 125 would give you a difference of 55. So N is equal to 55, and I'll write this over to the side to have a little bit more space here and box in my answer and all that. So we were looking for the length of side YZ. So I'm going to say side YZ equals 55, and then these were inches that we were dealing with here. So I combine the sides that I know the length for, and I subtract it from the perimeter, basically, is kind of summarizing the steps to do that. It works by basically creating that equation that I am going to solve. All right, and in this last example, I'm asked to find the length of side OV, which is right here. Again, you can highlight, or I could create a variable for that. I'm going to go with N. Again, you could use X. I just would not use a variable that is also one of the names of one of the angles. But we're asked to find the length of side OV if the area, so we're dealing with area this time instead of perimeter, of rectangle LOVE is 143 yards squared. So area is always squared. That's why it's yards squared. So if you remember, the formula for area of a rectangle is area is equal to the length times the width. So I'm just going to plug in some values that I have here. This is my area, the 143 yards squared. I'm just going to use the number portion of that, the 143, because when I type it in my calculator, that's all I'll use, is equal to, and I plug in values for length and width. So I'm going to make this bottom side here my length. Now I'm going to say that N over here, that's my width. And you could do it the other way around. It won't make a difference which you assign to length and which you assign to width, but that's how I'm going to assign it. So my length of 13 yards, I'm going to put in the place of L, and LW like this, remember that's multiplication, and my width is N. Or you could write that 143 equals 13n. Normally, when you are writing an equation and you have multiplication between a number and a letter, you wouldn't write the times symbol. All right, so now I have to isolate my variable, right? I have to get my n by itself. So I'll box that in. I'm going to do the opposite operation, which is to now divide by 13. In case you forgot that was division, that was multiplication and I have to divide, I actually had the multiplication symbol written originally. And I'm going to divide this side by 13, and this side cancels, and n equals whatever 143 divided by 13 is. So 143 divided by 13 would give me 11 exactly. So if n equals 11, that means that the length of side OV is equal to 11, and these were yards I was dealing with. So that is equal to 11 yards. So different ways that you can use some of the properties of our quadrilaterals to help you find not only a missing angle like we did in the last lesson, but also a missing side.